Find the Fourier series. Fourier series expansion of the waveform. Expansion of the waveform shown below. This is the waveform. X of t. This is the waveform shown below. Here 1, -1, 0, 1, 2, 3, 4. Here -1, -2, -3, -4. This is the waveform. Find the Fourier series. Examine the symmetry of this waveform. Here x of t is equal to minus of x of minus t. This is an odd symmetry. Odd symmetry. Suppose if x of t is equal to x of minus t, that is even symmetry. Here 1 is there, here -1 is there, here 1, -1, 2, -2, 3, -3, 4, -4. That is minus. That is a minus t. X of minus t. Here in the positive side, the value is 1. X of t amplitude is 1. In the negative side, x of t value is -1. That is the reason minus x of minus t. This one is odd symmetry. For odd symmetry, A0 is equal to 0, AN is equal to 0. Find out Bn. Find out Bn. Here, first of all, you have to find out the time period of the waveform. In so many ways, the time period of the waveform is measured. Suppose here, this one is a T0. Starting waveform here like that. This one is increases up to this point. This one is a T0 plus small T0 plus capital T0. Therefore, small T0 is equal to -1. T0 plus T0 is equal to 3. Substitute T0 value in that equation. T0 is equal to 3. T0 is equal to 3 plus 1, that is equal to 4. The time period of the waveform, this is the time period of the waveform is 4. In another way, the time period of the waveform is here. The wave is starting point here is here and here and here. Here T0 is equal to 0. T0 plus T0 is equal to 4. These are the 2 points. This is the time period T0. Therefore, T0 plus T0 is equal to 4. Put T0 is equal to 0. 0 plus T0 is equal to 4. Therefore, T0 is equal to 4. So many ways the time period of the waveform is determined from this given waveform, or else here this is the T0 -4, T0 plus T small d naught plus capital D naught is 0. Therefore, in that way also the time period of the waveform is 4. The time period of the waveform is 4. Time period. The time period of the waveform T naught is equal to 4. This one is an odd symmetry. The Bn equation is Bn is equal to 4 by T, general expression, 0 to, this is the time, T is the time period of the waveform. That is, T is replaced with T naught by 2 x of T sin n omega naught T dt. Here T naught is 4. Substitute 4 in that equation. 4 pi. T naught is, we know that T naught time period of the given waveform is 4. T by 4, that is 4 by 4. 0 to 4 by 2 x of T sin n omega naught is equal to 2 pi by T naught T dt. That is equal to 4 by 4 is 1. Integral 0 to 2 x of T sin 2 n pi by T naught is 4 T dt. That is equal to n pi by 2. N pi by 2. Here 0 to 2. Here 0 to, again examine 2 time periods. 0 to 2 means 0 to 1 value, 1 equation, 1 to 2 another equation. For this interval, 0 to 2 interval, we go for 2 equations. 0 to 1, some discontinuity is there. 0 to 1 equation, 1 to 2 another equation. Or else you have to choose the interval -1 to +1. Instead of 0 to 2 here, -1 to +1 is also same meaning. Here -1 to +1. The equation is like that, -1 to +1. It is also 1 minus of -1, that is equal to 2. In that case, only one equation, one straight line, one line passing through origin. Here, 0 to 2, 2 lines. This is 0 to 1 line, 1 to 2, another line. 2 lines are there. It has the same meaning. Therefore, instead of 0 to 2, we have to consider -1 to +1. Here 0 to 2 is replaced with -1 to +1 x of T sin n pi by 2 T dt. This is the Bn coefficient, Fourier series coefficient. Next, to find out how to find out x of T. Here, this one is x of T. This is the T. Straight line passing through origin here 0. Here 1. Here -1, because here 0 to 2 is replaced with -1 to +1. Meaning doesn't change. Here the value is here -1, here +1. Need not mention plus. That is 1 +1. We have to find out the total expression. This is the x-axis value 1. This is y-axis value 1. That is, in that case, the coordinates are 1, 1. Here from 0 to -1, the value is -1. negative time period. This is minus t, x-axis. Here y-axis is -1. Here the coordinates are -1, -1. Therefore, 1, 1, -1, -1. Find out the expression. Here x-axis is t, x is t, y-axis is x of t. Here x1, y1, x2, y2. Y is equal to, we know that y is equal to mx plus c, where m is called as slope of the line. Y is equal to a straight line passing through origin, that is y is equal to mx plus 3. Here y2 minus y1, y minus y1, not 2, y minus y1. The equation is y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Here y minus y1 is, here y is x of t, here y is x of t, here y is x of t minus y1 is 1, y2 minus y1 is -1, -1, y1 is 1, x2 minus x1 is -1, -1. That is x minus x1 is t minus 1, t minus 1. Therefore, x of t is equal x of t -1 -2 by -2 t minus 1. Therefore, x of t minus 1 is equal to t minus 1. X of t is equal to t minus 1 plus 1, -1 plus 1 cancel. Therefore, x of t is equal to t. X of t is equal to t. In the interval -1 less than or equal to t less than or equal to 1, the value of x of t is t. Substitute this x of t value in dn expression. Therefore, dn is equal to -1 to +1. The value of x of t is t sin n pi by 2 t dt. We know that t into x of t in the interval -1 to +1. The value of x of t is t sin n pi by 2 t dt. This is equal to, by using UV formula, by using first t into integral of sin n pi by 2 is minus cos n pi by 2 minus cos n pi by 2 t by n pi by 2 minus differentiation of t with respect to d by dt of t is 1. Again, integral of this one is cos n pi by 2 integral is minus sign here as it is sin n pi by 2 into t by here n pi by 2 into n pi by 2 whole square. Again, integrate this entire function. We will get this one. Therefore, in the interval 1 to -2, that is equal to minus into minus plus, right? Minus into minus plus sin n pi by 2 into t n square pi square by 4 minus t into cos n pi by 2 into t by n pi by 2. Here minus into minus plus. Write down this expression here. Write down second expression here. In the interval 1 to minus 1. Substitute these limits in that expression. That is equal to here 4 by n square pi square sine n pi by 2 t minus 1 to plus 1 here. Here n pi by 2 t cos n pi by 2 minus 1 plus 1. Substitute these values in that expression. 4 by n square pi square sine t is equal to 1. Whenever t is equal to 1, that means sine n pi by 2 minus lower limit t is minus 1. Sine of minus sine minus n pi by 2 is minus sine n pi by 2. That is minus minus plus sine n pi by 2. Here reverse. Two by n pi. This one is 2 by n pi minus 2 by n pi. Substitute t value is 1. Here substitute t value is 1. T into cos n pi by 2. Again t is equal to minus 1. Here minus t is equal to minus 1. Minus into minus plus. And the cos minus n pi by 2 is cos minus cos is an even function. Cos minus n pi by 2 is cos n pi by 2. That is cos n pi by 2. 4 8 n square 8 n square pi square sine n pi by 2 minus 2 by n pi 2 into 2. 2 into 2 is 4. 2 into 2 is 4. 4 by n pi cos n pi by 2. 4 by n pi cos n pi by 2. That is here bn is this one. We know that sine n pi by 2 is equal to minus 1 whole power n minus 1 by 2. N where n is odd. 0 whenever n is even. Similarly, cos n pi by 2 is equal to minus 1 whole power n by 2 whenever n is even. This one is minus 1. This one is minus 1. This one is minus 1. 0 n is odd. By using these equations in that expression, for even values, for n is even, sine pi, suppose n is equal to 2, substitute n is equal to 2, 2 pi by 2, 2 to cancel sine pi, sine 90 plus 90, cos 90, that is 0. This point is 0. This part is 0. This part is not 0 because n is equal to 2. 2 minus 1. Here substitute n value in that expression. N is odd. 3 minus 1. 3 minus 1 is 2 by 2. That is 1. Minus 1 whole power is 1. Minus 1. Substitute minus 1. Here cos of minus here sin n pi by 2 is here n is odd means n is odd. Suppose n is equal to 3. 3 minus 1 by 2. 3 minus 1 means 2 by 2. That is 1 minus 1. Sin 3 pi by 2 is not 0. Sin 3 pi by 2 is not 0. Suppose Bn is equal to 8 by n square 8 by n square pi square minus 1 whole power n minus 1 by 2. When n is odd, n is odd. For n is odd, cos n pi by 2 value is 0. Cos n pi by 2 value is 0. Bn is equal to minus 4 by n pi minus 4 by n pi. Cos n pi by 2 is minus 1 whole power n by 2. N is even. For n is odd, cos n pi by 2 value is 0. For n is even, sin n pi by 2 value is 0. Therefore, divided into two parts. Here, minus 1, 4 by n pi, minus 1, whole power n by 2. N is even. N by 2 plus 1, 4 by n pi. That is equal to minus 1 n plus 2 by 2 into 4 by n pi. This is for even. For n is even, n is even, the value of Bn is like that. For n is odd, the value of Bn is this one. Finally, therefore x of t for odd symmetry A0 An is 0. Therefore, x of t is equal to A0 An is 0. Sigma n is equal to 1 to infinity Bn sin n omega naught t. This term is only present because A0 for odd symmetry A0 An is 0. N is equal to 1 to infinity Bn sin n 2 pi by T0 into T. That is equal to sigma n is equal to 1 to infinity Bn sin 2 pi by T0 is 4. It is equal to n pi by 2 T. Sigma n is equal to 1 to infinity Bn sin pi by 2 T. This is the Bn value. This Bn has two parts, even terms and odd terms. That is Bn is equal to 1, 2, 3, 1, 3, 5, 7. The value of Bn is 8 by 4 pi n square pi square minus 1 n minus 1 by 2. For even values, for odd values, that means sigma n is equal to 1, 3, 5, 7 up to infinity. The value of Bn is for n is odd, the value of Bn is 8 by n square pi square 8 by n square pi square minus 1 whole power n minus 1 by 2 for n is odd. for n is odd. Suppose for n is odd, for n is even, the value of that means n is equal to 2, 4, 6, and so on up to infinity. That is 4 by the bn value is 4 by n pi minus 1 whole power n plus 2 by 2. This is into sine pi by 2 n pi by 2 t into sine n pi by 2 into. These are the two expressions. With this, the analysis is completed for this waveform.